this is an example of the product rule. So this is going to go ahead and be, we'll let v equal t squared. So the derivative of that would just be 2t. And then over here, that's u. So that's going to be 2 to the t. And then u prime is equal. All right, so let's go back for a second and just look what the rule is for this. If it was just d dx of e to the x, that just equals e to the x, right? And if there's anything inside there, if it was e to the, instead of x, if it was e to the u, then that would just be e to the u. This would be e to the u times u prime. But wait, okay, but that's not what we have here, because right now my base is not e. So whenever the base is not e, it's different. The d dx of any constant, it has to be a constant, to the x power is just going to go ahead and be a to the x times the natural log of a. Okay, so that's what the big difference is here. So then this would go ahead and equal 2t times the natural log of 2. So the product rule then is you're just going ahead and one of the sides is here. Do those two first, and that will give us 2 raised to the t times the natural log of 2 times t squared. And then we're going to go ahead and do the other one, which is this way. Yep. And that's just going to be 2t times 2 to the t power. And the only thing I can do with this is 2 to the t power. That's not easy to say. I can pull out and let's see if that makes it look any better. So then that would be t squared times the natural log of 2 plus 2t. And we're just going to go ahead and leave it like that. We could probably factor out one of the t's here if we wanted to. But then you would have 2 to the t power times t. And this would be still t, the natural log of 2 plus 2. It's probably the only other way you could simplify it. This is another example of the product rule, right? So this here is going to be u. U is equal to 2 to the negative theta. The derivative of u is just equal to 2 to the negative theta times the natural log of 2. And again, because that is your base. Then over here, all of this will be v. Cosine of pi theta. V prime, we need the chain rule here. The derivative of the cosine is minus the sine of pi theta, but you have to multiply that times the derivative of the inside, right? This is where the inside stays the same, and then you have to multiply it times the derivative of that inside. So the derivative of that would just equal to positive 2 to the negative theta. And I'm going to pull the pi out front, so that would be negative pi sine of pi theta plus the natural log of 2 times cosine of pi theta. 69, with this, we have a problem here, because the problem is my base, right? All of this inside underneath here is my base. This is not a constant. And when it's not a constant, you can't leave it this way. So what you have to do is you have to take the natural log of both sides, which starts to look really weird. But now I have the natural log of y is equal to the natural log of the natural log of x to the cosine of x. Now, because it's natural log, I can take all of this and pull it out front, which now gives me the natural log of y is equal to the cosine of x times the ln of the ln of x. This equation in terms of y and x, so now you need to use implicit differentiation, correct? So we're going to go ahead and use the fact that the derivative of the ln of y, that's just equal to 1 over y. But because that's in terms of y, I need to write that as dy over dx. Over here, I need the product rule because I have the cosine of x and I have the ln of x. And when I use the product rule with that, I'm going to have to be very careful because for that one, I'm going to need the chain rule. So I'm just going to go ahead and write it out just to make sure. I know that u is equal to the cosine of x. U prime is just going to be minus the sine of x. And then for v, v is equal to the ln of x. Becomes v prime, which is 1 over the natural log of x, because you needed everything on the inside of that natural log. Now I'm using the chain rule, correct? And the chain rule for this one, when I'm using the chain rule, I'm taking the derivative of ln of x, and that is becoming your 1 over x. So v prime is actually 1 over x ln of x. Okay, so then I go ahead and start with the derivative of the cosine, which is minus the sine of x. I multiply that times what I started with, which is ln of x. And I'm going to run out of room here, but I'm going to add that to the cosine of x times, I'm just going to put it over that, over x ln of x. So dy dx is equal to, I'm taking this y, multiplying it times both sides. And then in here I just have minus the sine of x ln of the ln of x plus cosine of x over x ln of x. No, but the problem is we don't really need to because the question goes on to ask us to find the tangent line. Not yet. So we have to find the tangent line because first we have to find the slope. So the tangent line is going through e, comma 1. So what is y prime equal to all of that? Well, y was equal to 1. So this y just becomes 1. And everything inside where x would be, it's going to be an e. So I have minus the sine of e. This is the ln of e plus the cosine of e all over e ln of e. And this is where we get to be very happy that it's the ln of e, because the natural log of e is just equal to 1. So the natural log of e there is equal to 1. The natural log of e there is equal to 1. So now I have y is equal to minus the sine of e. And the natural log of 1 is just what? Yep, that's exactly right. And that's what makes this so nice, because all of this is times 0. So all of that gets crossed off. And now all I'm left with is y is equal to the cosine of e all over e. And all right, so this is right. Oops, I forgot my mark. That's the that is what y prime is equal. So really, what I'm saying here, this is equal to the slope. So that's m. So because now I need to plug that into y minus y1 is equal to cosine of e over e, x minus x1. And x1, our point was e, right? So that becomes e. Y1 was 1. So all of this now becomes y minus 1 is equal to the cosine of e over e times x minus e. The thing with this question is this is in the form of the integral of u prime. So it's in the form of u prime over u du. This is difficult to see. But if I look at this, if I let u equal 1 plus 3 to the 2x, then the derivative of u, the derivative of 1 just goes to 0. And then the derivative of 3 to the 2x, no, it's 3 to the 2x times the natural log of 3. Making sure we put it back in the correct units to make sure this is equal to du over dx, right? Is equal to the natural log of 3 times 3 to the 2x. But we have to remember that this is 3 not just to the x but to the 2x, so we have to use a chain rule here again and multiply that times 2. So what we end up getting here is du over dx is equal to 2 times 3 to the 2x times the natural log of 3. Okay, so once we have that, we can go ahead and isolate and solve for dx. So dx just becomes equal to du all over 2, 3 to the 2x times the natural log of 3. So now we take dx and we're going to substitute that back in up here for. So now I have the integral of 3, 1 plus 3 to the 2x times dx, which we will be replacing with du over 2 times 3 to the 2x times the natural log of 3. And I realized when I copied this over from the top, we need to make sure that is 3 to the 2x. Sorry about that. So what we have here is those two will go away. The 2 and the natural log of 3 will come in the front of the integral. So that gives me 1 over 2 natural log of 3 times the integral of du all over u. And again, that is what we let all equal u, which just equals 1 over 2 natural log of 3 times the natural log of the absolute value of u plus my constant. And to substitute u back in, I just get 1 over 2 natural log of 3 times the natural log of the absolute value of 1 plus 3 to the 2x plus my constant. Now, inside here, there's no way that this would ever be negative, so I can go ahead and drop that. And then I would just be left with the natural log of 1 plus 3 to the 2x all over 2 natural log of 3 plus my constant.